Hello and welcome to 3D Nato. In today's video, I'll show you step by step how to make this D20 dice in Blender. First, let's clear the scene. Press A to select all objects in the scene, then press X to delete. Now we'll set Blender to use millimeters. Go to the Scene tab, open Units, set the unit scale to 0.001, and under Length, choose millimeters. Let's add our base mesh. Press Shift+A to add, go to Mesh, and then select Icosphere. This shape is perfect for a D20 because it already has 20 faces when subdivisions are set to 1. Before we move on, let's adjust the size and subdivisions. To do this, expand the Add menu. D20 dice usually come in 3 sizes: Mini from 10 to 12 mm, Standard from 22 to 25 mm, and Oversized from 40 to 55 mm. For this tutorial, we'll make a standard D20. Set subdivisions to 1, and for radius, type 25 mm divided by 2. Now let's make our dice look more realistic by softening the edges. On the right side, open the Modifiers tab, click Add Modifier, go to Generate, and add a bevel modifier. In the bevel settings, set the amount to 0.225 mm and segments to fall so the edges curve smoothly. Next, scroll down to the shading section and enable harden normals to improve the lighting. And finally, set the material index to 1. This tells Blender which material slot to use for the beveled edges. The mesh is ready. The next step is preparing the UV map to create the texture. Switch to the UV editing workspace and we'll set that up. Blender has already created the UV islands for us, so now we just need to line them up and export the layout. With the UV island selected, go to the UV menu and choose Arrange Align Islands. In the Arrange Align Islands menu, let's adjust a few settings. Set initial position to UV grid, axis to X, and align to center. This will center everything in the UV space. Next, we'll export the UV layout so we can make the texture map. Go to the UV menu again and select Export UV Layout. Choose the folder where you want to save it and export it as an AKPNG file. With this UV layout saved, we can move into an image editing program to design the texture map. I'll be using Affinity, but you can use any software you're comfortable with. The first thing you'll do in Affinity is create some guidelines using the Pen tool. Select the Pen tool and draw a horizontal line between 2 UV triangles. Repeat this until you have created 10 horizontal lines across all the UV triangles. These lines will make it much easier to place the numbers correctly on each face. Once all the lines are created, drag them underneath the UV layout layer. Now let's add the numbers with the Text tool. I'm using the Rubik font, regular style, size 600 points, and center alignment. Click with the Text tool, type 2, and press Escape to finish. Next, we'll duplicate this number to create the rest. Press V to switch to the Move tool, then holding Shift+Alt, click and drag to make a copy. To create more copies, press Ctrl+J 3 times to complete the first row. Select all the numbers in that row, then repeat the same steps to create the other 3 rows. Here's something important to keep in mind. On most D20 dice, the sum of opposite faces is 21, so we'll follow this sequence. On the first row, set the first number to 2, the second to 20, the third to 14, the fourth to 4, and the fifth to 18. On the second row, set the first number to 12, the second to 8, the third to 6, the fourth to 11, and the fifth to 5. On the third row, set the first number to 10, the second to 16, the third to 9, the fourth to 13, and the fifth to 15. And on the fourth row, set the first number to 17, the second to 3, the third to 19, the fourth to 1, and the fifth to 7. Once all the numbers are created in the right order, drag them under the UV layout layer. Now we align them with the guidelines. Select Align, then Shift select the number, go to Align, choose Align Center, Align Bottom, then Apply. Now repeat these for all the numbers in the first row. For the second row, select a number and rotate it upside down. Select Align, then Shift select the number, go to Align, choose Align Center, Align Top, then Apply. Now repeat these for all remaining numbers. Just remember, rows 1 and 3, align center and bottom. Rows 2 and 4, align center and top, rotated upside down. Next, let's position the rows. Select rows 1 and 3, hold Shift, and press the up arrow 17 times. That's 170 pixels. Select rows 2 and 4, hold Shift, and press the down arrow 17 times. Finally, underline the numbers 6 and 9 so they don't get confused. To keep things organized, let's group all the numbers. Select them, press Shift+G, and rename the group numbers. Do the same for the lines, then hide both the lines in the UV layout by clicking the eye icon. The mask map is finished. Export it as a JPEG file, and we are ready to go back into Blender to create the materials. Now it's time to create the materials, so switch to the shading workspace. Along with the mask map we made, I'll also use the Plastic 17 PBR maps from ENDSCREEN. I'm using the 2K JPEG version, and you'll find the download link in the video description. Let's start by creating the base material. Click to add a new material and rename it D20 base. This will be the foundation for everything we build. Now we'll add some nodes to shape how the material looks. Press Shift+A to add, go to Input, and add a Texture Coordinate node. This node tells Blender how to wrap images around the mesh, in this case, using the UV map. Press Shift+A to add, go to Utilities, Vector, and add a Mapping node. This won't let us move, rotate or scale the textures, so we can adjust how the plastic pattern fits. Press Shift+A to add, go to Texture, and add an Image Texture node for the mask map. Press Shift+D to duplicate it for the Plastic 17 roughness map, and Shift+R to duplicate it again for the Plastic 17 normal map. Press Shift+A to add, go to Color, and add a Mix Color node. This blends two colors together, and the mask map will tell Blender where each color should appear. For Surface Detail, press Shift+A to add, go to Displacement, and add a Normal Map node. This converts the normal texture into shading information, making the dice look more realistic. Then press Shift+A to add, go to Displacement, and add a Bump node. This one uses grayscale images to simulate height differences, perfect for making the numbers look engraved into the plastic. Together, these nodes create a convincing plastic material. The mask map controls the colors, the roughness map defines shininess, and the normal and bump nodes add depth and detail. Now let's connect the nodes to actually build the material. Since the mask map can't be moved, rotated or scaled, we'll connect the UV output directly into the first image texture node. Next, take the UV output again and plug it into the mapping node's vector input. From there, connect the mapping node's vector output into the other image texture nodes. This way, we can control the scale and placement of this texture if we need to. On the first image texture node, click Open, load the mask map, and set the color space to non-color. This tells Blender it's not a regular image, but data for the shader. On the second image texture node, click Open, load the Plastic 17 roughness map, and set it to non-color. This map controls how shiny or matte the surface looks. On the third image texture node, click Open, load the Plastic 17 normal GL map, and set it to non-color. This one adds defined surface details, like scratches and bumps, to make the dice look more realistic. Let's connect everything together. First, connect the mask map's color output into the Mix Color node's vector input. The vector decides how much of color A and color B are blended. The black areas of the mask will show color A, and the white areas will show color B. In this case, the numbers will be color A, and the dice body will be color B. On color A, I'll set it to a bright yellow. If you want to use the same, the hex code is FFD700. Then for color B, I'll set it to black. Connect the mixed color result into the principal shader's base color. Next, connect the plastic roughness map into the principal shader's roughness input. This controls how shiny or matte the dice looks. Now connect the plastic normal map into the normal map node. Then connect the normal map into the bump node's normal input. For extra detail, connect the mask map's color into the bump node's height input and set the distance value to 1. Finally, connect the bump node's normal output into the principal shader's normal input. At this point, the base material is complete, and to handle the bevel corners, we'll duplicate it. Remember, we set the material index to 1 for the bevel modifier, meaning they'll use a separate material slot. Click the arrow next to slot 1, then click the plus sign to add a new slot. Browse for the D20 base material and assign it. Now unlink it by clicking this little 2 icon to make it a single user copy and rename it D20 bevel. For this bevel material, we'll give it the same yellow as before. Disconnect the mixed color from the base color, then simply copy color A by dragging it over. Now the bevel corners match the dice numbers, completing the look. And that's it. You've just made a D20 dice in Blender. If you found this tutorial helpful, don't forget to give it a like. It really helps the channel grow and let me know you enjoy this kind of content. And if you want more Blender tutorials and 3D projects, make sure to subscribe and hit the bell icon. Thanks for watching, and I'll see you on the next one.